Hello again. Today, we're in the chapter on carboxylic acids, and we're gonna start looking at some reactions of carboxylic acids or reactions to synthesize carboxylic acids. And today, I'm gonna focus on um, one of the things I may focus on is the Fischer esterification, and this is going to be kind of part one of a multi-part series. And this, I'm just going to give a general reaction scheme and a couple examples of it. Okay. And so our general reaction of a Fischer esterification is we're going to take a carboxylic acid. There we go. There's our carboxylic acid. So carb acid, and that's going to react, make this R prime, with an alcohol, and then we're going to have some source of acid here, another acid, okay, and we ultimately make an ester, shown there, plus H2O, water, okay? And our new bond is going to be right here. It's this carbon-oxygen bond. That's going to be the new bond that we make in this reaction. The acids that we typically use are going to be, I've often seen sulfuric acid. It could also be para-toluene sulfonic acid, TSOH, or potentially hydrochloric acid. Okay, so these are all fairly strong acids. Okay, another thing that I will probably talk about more in a future video is this is a reaction where the equilibrium constant is fairly close to 1. Okay. I think the book says our textbook says 3.38 for some Fischer esterification. So that means that at equilibrium, we do not favor the products very much. And we'll talk about some tricks we can do to get products, tricks or science, okay, in a future video. But let me give you some examples here. Okay. I guess flying is a trick based on principles of physics. Okay. So let's take an example here. So we'll call this example 1. All right. Pick your favorite carboxylic acid. This probably isn't people's favorite carboxylic acid. It kind of smells like butter that's gone bad, but this is butanoic acid. And I'm going to react that with an alcohol. Gotta watch my board management here. Don't want to run out of space. All right, so I'll use benzyl alcohol. That's a pH, lowercase h. All right. And I'm going to use sulfuric acid as my catalyst here. All right. And to figure out what this is going to be, this oxygen is going to bond to that carbon, the carbonyl carbon. Okay. And so my ester is going to look like this. Plus water. Okay. There you go. Let me give you another example. This is going to be a tricky example. Okay. Anything that's intramolecular is 1, 2, 3, 4. Got to be careful here. 1, 2, 3, 4, 5. Okay, so what's tricky about this example is I have placed the carboxylic acid and the alcohol in the same molecule. Now here it's good to kind of count what's going on. 1, 2, 3, 4, 5. All right. So the alcohol, and I'll show the mechanism in probably the next video. The alcohol, we're going to form a bond between that oxygen and that carbon. All right. Again, this is at equilibrium. The equilibrium constant's close to 1. I'm going to use tosic acid here. And my ester is going to be a 5-membered ring. All right. Plus water. Okay. Let me number that ring for you. 1, 2, 3, 4, 5. This is a cyclic ester. We could also call it a lactone. Cyclic ester is a lactone. Okay. One other thing I want to talk about here is because this is an equilibrium, we can have the reverse reaction occur. And the reverse reaction is called an acid catalyzed ester hydrolysis. Okay, so it's the opposite. So esterification is making an ester. Ester hydrolysis. Okay, so acid catalyzed ester hydrolysis. We're going to use water to break apart the ester. Okay, so let me give you an ester here to break apart. We'll just put an ethyl group here. That's ET, honestly. Okay, and let's just put an isopropyl group here. Okay. And so to do ester hydrolysis, we're going to need some acid and we're going to need water. Okay, so, and the way you want to think about this, we're going to break this bond. I call it the ester bond. And then we're just going to add H2O basically across that. And so our products are going to be the alcohol plus this carboxylic acid here. Okay? So we want to be able to go both ways. We want to be able to form the ester and also predict the products of the ester hydrolysis as well. All right, so that's going to conclude our introductory video on the Fischer esterification and hydrolysis of esters under acid catalyzed conditions. In probably the next video, I'm going to go over the mechanism of this reaction, and then I'll probably have a third video talking about how we can shift this equilibrium in one direction or the other. Thanks for watching.